Okay, we are now recording. I'll start recording from the current slide. I will start recording here. First thing I want to do, are there any questions on that first quiz? And again, I won't answer the quiz question, but I'll answer anything similar to it you can find in the book. Or I'll explain what I'm asking for. Were there any questions off that first quiz? Okay. Now, technically, it's due Wednesday because I gave it to you last Wednesday. I always try to give you 1 week to work on your quiz. So try to get it in by Wednesday. So because we're finished with chapter 10, and I want to give you the test, but you got to get the quizzes done before I give you the test so you'll know what to expect. I will give you another quiz today. This one will not be optional. This one will count. I'll give that to you before we leave. It's also in chapter 10. It's much closer to what the test will look like. Okay? Not exactly what it'll look like, of course, but it's much closer. Okay? So any questions on the quiz I gave you last time? Yes? Okay. You have to give me something a little more specific than that. Okay? Wait just a second. Let me get Greg Joy here. Right? Okay. Now, did you get a quiz last time?
Yeah, I got a quiz.
You did. Good. Okay. Pick a question, any question. Number three. Okay. Number 3. Simplify the given expression. Okay. Now, and here's what I mean. Let me get this marked. Okay. See if I can get one as close to it as I can. This is what I hope you will be doing, is finding one similar to it in the book. And well, I would say the closest I can see in the text thought I had it, but it's not quite the same. Yeah, okay. All right, let me get names, please.
Right.
Al, right? Say again? Darren Payne. Okay, I know you're in here. There you are. And Al, right? Okay. Anyone else come in since the call roll? Okay. Now, did either of you not get the quiz I passed out last Wednesday? You got it? Got it?
I don't have it.
Yeah, but you got a copy. Did you lose it, or you just is it? Oh, okay. So you got it. All right. Okay. I had a question on it, number 3, and I'm going to expand on it just a little bit. If you go to page 688, okay, bottom of the page it says simplify each expression. Okay, I'm going to do 54 if that's okay. Let me get my pen set up. -7 times -4 plus 3x squared y. This is, okay, I'm changing it slightly. It's page 688. I'm making it a little more complicated so it'll match more like this one is. Okay? Close parentheses, plus 5 times x squared y minus 6. Now that's not exactly like the 1, but is that going to be close enough for you, you think? Okay. All right. Can y'all see what I've got here? Some of it wrote into here, but I hope you can read that. What would be your first step? Okay. Say again? Okay. First thing we do is what I call clearing parentheses. The better term for it is distributing across the parentheses. So the minus 7, which is on the outside, you distribute across the parentheses to each term inside and clear those parentheses out of the way. So, first one would be what?
28.
28, because negative 7 times negative 4 is positive 28 minus 21 x squared y plus 5 x squared y minus 30. Okay. Joseph, right? Okay. There you are. All right. Did you get a copy of the quiz last time?
Yes.
Okay, good. We're not answering one of the quiz questions, but one's fairly similar to it. Okay, so the first thing we did was clear the parentheses by distributing what's outside across the parentheses to what's inside. Now the question is, what's the next step?
21x.
A little louder?
21x.
Okay.
Squared plus 5x.
Okay, so we're combining like terms is what it's called. Here we have a negative 21x squared y, is that what you were saying?
Yeah.
And here we have a plus 5x squared y. Do those combine?
Yes.
Why?
Because it's like
Exactly the same variables at exactly the same powers. So that would add to be what?
Negative 16 x squared y.
Negative what?
16.
Yeah, negative 16x squared y. I can't write very well. And what else? Minus 2, because the two constants are also like terms. 28 minus 30 would be minus 2.
Why is it cubed rather than being squared?
What's that?
Why is it cubed rather than being squared?
I can't hear.
Why is it cubed rather than being squared?
Okay,
Why is it x cubed instead of x squared?
okay, why is it x?
Why is x squared? Why is it not combined to those numbers?
Okay. When you combine these two?
Yeah.
Okay. I think of it this way. Minus $21 plus $5. Can I square my dollars? No, it's just minus 16. I owed you $21. I got $5, so now I paid you $5, now only owe you. These are just names. These are your variables. You don't combine those. You only combine the number parts. Okay? The variables stay with it just like they are. Now, if you were multiplying them, yes. Okay? If you're multiplying this by that, then that would be negative 105 x fourth y squared. If you multiply every part. When you add or subtract, that's just the name of it, x squared y. You know, apples, oranges, whatever. Minus 21 apples plus 5 apples, okay? You still have just apples, okay? That's probably a dumb illustration, but does it kind of make sense?
Yeah.
Okay. All right. Does that kind of answer what you were asking? Okay. So the one on the quiz, okay. Let me change this one ever so slightly one more time. And minus 7 times a minus 4xy squared plus 3x squared y plus 5x squared y minus 6. Okay? What if I had some variables stuck on this one? Now what would we do? This is going to be closer to one you have on your quiz. Say again? Okay, and what would it be? 28 xy squared minus 21
x squared y
x squared y
plus
plus
5x squared
x squared y
minus 6.
minus 30. Okay. Now what do we do?
30.
30. I can't read. Right. Okay. 30. Okay. Minus 30. Okay. Now what? Combine like terms, and what like terms do you see?
The 28 and the 5.
Say again?
The 28 xy squared and the 5x squared.
Okay. They have to be identically the same variables at identically the same power. These are not. These are the same because they're identical here. This is not because it's xy squared. And that's the thing that made this problem a little more difficult, is that they had some that were xy squared, x squared z, and the other xy squared. Okay? I actually made it a little more complicated. But these two you can combine. You can't combine this with either one of them because it's not at the same power. The variables have to be identical. Coefficients don't have to be, but the variables do. So what would that answer be? 28x y squared. There's nothing else that can combine with that. Next, minus 16x squared y minus 30. Okay. Now, it says write the answer with variables in alphabetical order and any constant term last. That's just sort of standard. It didn't matter which one you wrote of these first. The one they had on the quiz started with a y squared z and then an xy squared. Technically, you should have written the xy squared first, x squared y first, and then the y squared z. But that's really not as important as getting the combinations right. So don't sweat that. If you got the right answer, I'll give you credit for it. Okay. Is that kind of any others? You said any of them. So any others? Yes. 9. Okay. A much better problem, I think. Oh, and this is, we'll call this quiz 1, and that was number 3, or like 3, though it wasn't 3. Let's do number 9. Okay. And I swear, I do not know, I don't know who made this up, and I don't see many in here that are similar to this. So, oh, here we go. No, not quite. So what I'm going to do is just change things around a little bit. 9. That will be 4y cubed over 5 times 30 over y to the 4th. And again, I don't know where this came from because we haven't done anything quite like this here, so I'll just give you this to do. Where would you go with a problem like that? Say again? Okay, I think you're saying the right thing, but that's not the right terminology for it. But it's okay. What do you mean by that?
Take the 5 out of 30.
Okay, 5 will go into 5 one time, and 5 will go into 30 6 times. I thought that's what you were meaning. Anything else? Say again? Yeah, y cubed will go into y cubed one time, but y cubed will go into y 4th how many times? Did someone say something? Y times, not one time, y time. And I'll show you why. Okay? If we wrote this out, that 4y cubed would have been 4 times y times y times y. That's what y cubed means, right? Over 5. Okay? And that's multiplied by 30. I'm going to write that as 5 times 6, right? That's 30, right? Over y times, what's y fourth? Times y times y. Why not? Okay, now, what can we do? Obviously, 5 will go into 5 one time. That's where we got our 6. And this y will divide out that one. This one will divide out that one. This one will divide out that one. And we have 1 left. Not a 1, but a y. 1y. Okay? So you be careful when you do that you do. So what is your final answer? In your numerator? 24. And in your denominator? Y. Why not? Okay, 24 over y. Great. Okay? And again, that's not exactly the one on the quiz, but it's like it. Yes? Okay. There wasn't a negative in that problem, was there?
No.
No. Right. If any place there had been a negative, then here's what you do. And they're multiplied or divided. Count your number of negative signs. If it comes out even, the answer is positive. If it comes out odd, the answer is negative. That's the easy way to do the negative sign. Yes, sir.
Can't you put like a 1y in the sign?
1y would be fine. If you put a 1 down here, perfectly fine. I count either one of them correct. Yeah. Excellent. Good question. Any others from that quiz? Okay. Any others at all? Yes. Wait, okay.
To the third power? It wasn't to the fifth power.
Okay. Yeah, I just made up the problem, said 4y to the third power.
Oh, okay.
Yeah, it wasn't the same problem, I changed it. Okay, wait, okay, I think I got yours first. What?
17.
17. All right. Good question. I'm going to erase what we got. All right, to erase what we got so far? Yay?
Yes.
Okay. 17. Let's call it 5y plus 1 over 5 is equal to 1 over 6. It's not the same problem, but it's similar to it. Similar to 17, okay, on the first quiz. All right, now, wait. Why did I do that? We have done them like this. I know we did. Okay, let's do, how about number 35? Let me go on and erase this. Okay, and we'll do page 697. Is 35 look okay to you? Is that similar enough to that one? It's actually a little bit harder problem, but I think it'll be fine. Second? On the top of page 697, number 35, from your text. Okay, is that similar enough to number 17 on the quiz? Okay with it? Second? Okay, we'll do that one. That will be 3/5 t minus 1/10 t is equal to t minus 5/2. Good, thank you. What do we do in a problem like that? I knew we had done sums like this. Now this is actually more complicated than number 17, but it's similar. What do we do here? Find the least common denominator. What would that be? 10. Okay, what do we do with it?
Multiply everything else.
Okay, because this is an equation, we can multiply everything on both sides of the equation by that 10. If this was an expression that we're simplifying, then we find the least common denominators and go with that. This one with the equal sign, it's much easier to do with the equation. So the least common denominator is 10, so we'll multiply this by 10. We'll multiply this term by 10. We'll multiply this term by 10. And this term by 10. All right, that 10 on that side. Okay, first term, what do we have?
Times 2.
Okay, 6t, because 5 will go into 10 twice. 2 times 3 is 6t, minus 1t, so I'll just put a minus t. That's equal to, no, that's my ugly writing, that's a 10t. Remember, we multiplied everything by 10. Minus 25, because 2 will go into 10 5 times. 5 times 5 is 25, right? Okay. Now what do we do? Combine like terms. On the left, what do we have? 5t is equal to 10t minus 25. Now what do we do?
Or add 25, either one.
Okay, you decide.
Minus 10.
Okay, you want to subtract 10t from both sides? Is that what you're saying?
Yeah.
Okay, that's a legal move. Minus 10t from both sides. And what does that give us?
5t.
Negative 5t is equal to, that goes to 0, negative 25. Now what? Divide both sides by negative 5. And what does that give us?
5.
T is equal to 5. Okay? And you should go back and check the answer. Let's just do it quickly and see. When you put a t in for 5, 5 in for t, that would be 3, right? Because this 5 cancels that one out. That would be 3 minus 5. Wait, let's see. I'm sorry. 3 minus 1/2, which would be 2.5, is equal to 5 minus 2.5, which would be 2.5. Yeah, so that works. Okay? Does that help? Make sense? All right. Any others? There was another hand up somewhere over here. Greg Joy, did you have one?
Is that negative?
What's that?
Is that negative 3t equals negative 25?
Okay, you're making fun of my writing, I can tell. Okay, it's negative 5t because it's 5t minus 10t is negative 5t. Is that what you meant?
Yes.
Yeah, okay.
8.
Second?
8.
8. Okay, let me back up to 8. Now again, this is not one that we had in chapter 10. So where they got this problem, I don't know. Was this something you did in 090? Okay, that may be where it came from then. So I'm going to make up something here. This will be number 8, similar to it anyway. Let's make that 26. P to the 6, Q times R to the 9th over yep. Let me change that 26 to a 27. Yeah, I'm making up a different problem. Okay. Hold on just a second. It's QR to the 9th. Is that what you're asking? Okay. Let me change that to 27. Okay. And then the denominator will have 18. P to the 5th. Q R to the 10th. Okay. Now, how would we do something like that? It's not the same one, but it's very similar to what's in the text, in the quiz.
Get rid of the P.
Okay, divide out a 9. Is that what I heard? Okay. 9 will go into 27. 3 times. 9 will go into 18.
2.
Twice. Very good. Then what?
P.
It's going to be a P because 5 P's will go into 6 P's 1 P time. Right? Okay. Next.
QRS.
Well, no, the Q's will go out. Q over Q is 1.
R.
So they are. And then what do you have here?
Q times R.
Yeah, they're together.
R.
Where?
This is R.
Where?
R in the bottom.
In the bottom. 9 R's up here will go into 10 R's down there, R time in the denominator. So what you have 3
P.
P over 2 R. See how it works? Yay or nay?
You do that?
A nay.
Nay. Okay, what is it that's confusing about it?
Put Q and R together.
Second?
Put Q and R together. Everything is separate.
No. Those are separate variables, separate letters. Yeah. Every letter is itself, you know. It's not QR, you know.
It's Q to the
It's
first.
Q times R. Anytime you see letters written next to each other, there's a time sign understood to be in between each one.
That or do Q to
That's
the first.
P.
So they're not together, they're separate.
That up here would be P times P times P times P times P times P. That's P to the 6 times Q times R 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 times R. Okay. Every one of those, think of it as a time sign in between. Yeah.
So going back to the other equation where you have X and Y, and doing them together, can't you split those up? Too?
Yeah, they were okay. But that one, okay, you're talking about number 3, the one like 3?
Yeah.
Okay, those were adding and subtracting. Okay, when you're adding and subtracting, you go by like terms. When you're multiplying and dividing, you can multiply or divide out anything, numerator and denominator. Adding and subtracting, you have to have the same thing. It's like adding, okay. I don't know if this will make sense to you, but let's try. I was driving from here to Tuscaloosa, okay? I started off the first part of my trip at 45 miles per hour. Why, I don't know, but I did. And then I added 5 miles per hour. That gave me 50 miles per hour, right? You're adding things. But if I said I drove at 45 miles per hour times 3 hours, I would get way past Tuscaloosa, but that would be miles per hour times hours. The hours cancel out because that's multiplied, and that would give me so many miles. What is that, 135 miles or something like that. So you see, when you're adding things, you keep the units or the letters. When you're multiplying things, they can divide out. Okay? Does that make sense?
Another way you can look at it is just
Yeah.
put a 1 exponent at the top. You subtract them.
Yeah, okay, yeah. And that is another way. You can think of this as, for the Q, that's Q to the 1, and that's Q to the 1. And then like he was saying, P to the 6 and P to the 5th, 6 minus 5 is 1, that's where you get P to the 1st.
You subtract the bigger number, and you always, the bigger number is where the exponent stays.
Yeah, and over here, since the 10's in the bottom, that's the one that
Yeah, be
is
10
what you're
minus
saying.
9.
But here, the Q1, 1 minus 1 is 0. What is Q to the 0th power? Yes, anything to the 0th power is 1. 4,583,813 to the 0th power is 1. Anything to the 0th power is 1. Yeah.
Why is that?
Because-
like literally in my high school, just like got up one day and they started no explanation, no real value or purpose. So
Okay. I couldn't hear all that.
I'm saying what I'm saying is like they literally got up one day and decided to teach us this in high school. They didn't put any type of real world application for any of this. So
Okay.
you know what I'm saying?
Okay. I missed the first part of it, but I caught the second part. No real world application.
Yeah, there's no real application. They literally got up one day and just started teaching us this and they explained how it works and everything, how that relates to
Okay. This is back in high school, you're saying?
Yeah, I mean, what you just talked about the miles per hour, yeah, that's one thing. Right?
Yeah.
That works, but,
Yeah.
it feels like you kind of do anything.
Well, some people just go by rules, and I like to give examples.
Yeah, that's good, yeah.
Okay. Just my weirdness, I guess. Okay. All right. Was there something else? Someone was saying something else, right? Oh, does that cover it all? Any others on the quiz? Okay. All right. Well, then, if you haven't finished the quiz, keep working on the quiz. And again, this one will be optional. The one I give you at the end of class today will be one that I'll count. Okay? It's much closer to what we did in class than this one. Sorry, I did this one thinking it was similar, and when I looked at it, I went, yuck, so. All right. So, no more questions on Chapter 10? All right. Then let's start on Chapter 11. All right. And any questions you have, and when I give you the quiz today, again, on Wednesday, you can ask me any questions on it. Find them in the book. These you'll be able to find much easier in the book than these did. Okay? So let's erase all that ink. So Chapter 11 is now talking about graphs of linear equations and inequalities, so we're not going to do that much with inequalities, in two variables. Okay? And here what we'll be doing. We'll start with talking about the rectangular coordinate system. There it is, right there. That almost looks like a square coordinate system, but a square is a rectangle. Okay? And what we're going to be doing here is interpreting graphs. We'll write a solution as an ordered pair. Now, we'll get into what that is. You probably have already run into it. We'll decide whether a given ordered pair is a solution to a given equation. That will be evaluating things. We will complete ordered pairs for a given equation. Okay, that sounds like a lot of the other stuff. Complete a table of values. Some places call those the t-tables, okay, whatever you want to call them. And we'll plot ordered pairs. Ordered pairs are all over the place here. So let's see. Goodness gracious, they skip example 1, okay? So let's start with example 1, okay? Now this indicates that you may have had something in Chapter 9. Did y'all do Chapter 9 in 090? I doubt it, but I don't know. I don't teach 09, or I haven't taught it in years. So, but 11.1 starts with interpreting graphs. And they didn't give us one. There is one in the book, and that's what example 1 is. I can't really show it to you here, but I can make this one seem almost the same thing. Okay? I'm going to do this, what they call a line graph here. I'm going to make it into a bar graph. And it's a pretty easy thing to do. I will just make that value a bar. Ooh, an ugly bar, but a bar. This one a bar. This one a bar. You see, it really doesn't matter which kind you have. And these look like they're quizzes out of a total of 10. So they're really short quizzes. There's quiz 5, quiz 6, quiz 7, and quiz 8. Now, it's not the same one you have in your text, but it's similar to it. This is just a bar graph, okay? In your book, those are years, and you're talking about how many dollars you spend on health care, and that's probably realistic. That number goes up every year, it seems like. This one, these are your quiz scores, okay, out of 10. Looks like you got probably a 8 3/4 on that one, maybe a 7 on this one, a 9 on that one, 5 on that one, 7 3/4 on those two, 7 on that one, and a 7.5 on that one. It's just a bar graph, okay? I could have colored those in, but I won't take up the time to do it. Okay, now, so example 1, the bar graph in the figure in the book, or this one here, shows the annual per capita spending on health care in the U.S. from 2004 to 2009. The one in the book, okay. Not all of you have books, do you? Do any of you not have books available? Okay. Well, let's just skip the rest of those questions then, and let's go on and do example 2. This is this isn't the same either. Why in the world do the PowerPoints not match what's in the book? But let's see if we can answer the questions here. Okay. I'll erase that ink. All right, the line graph here in figure 2 shows the average prices of a gallon of regular unleaded gasoline. This is the one in your book from 2004 to 2011. Nowhere close to what this is. This is the quiz. It says here, the line graph below shows the quiz averages on the first 8 quizzes in a college math course. Okay? Let's see if we can answer the questions here. Between which 2 quizzes did your score go down? Decrease. Between what? Yeah. Well, start with this one. Between 1 and 2. Between 3 and 4.
6 and 7.
And between 6 and 7. Perfect. Okay? Similar type questions to what they have here. Why they're not the same, I don't know. What was the general trend on the average price of it? Well, I'm sorry. What was the general trend on your quiz scores? What would you say? It seems to be gradually going downhill, but not too badly. The general trend, you started up here and wound up down to here. Okay? But there was a lot of fluctuation there. Okay? The one in your book, it generally was going up. There was 1 year it went down, the other years it went up, so generally it was going up. Your health care and that one, if you have that one in your book, going up every year. Okay? That's about what we see. Number C, estimate the average quiz score on these 8 quizzes. Estimate. What would be a good estimate here? Just looking at it. Second? What would be your estimate of your average quiz score? 7.5 looks pretty good to me too. Here we have 1, 2, 3, 4 above 7.5, 1, 2, 3 below 7.5, 1 right at 7.5. So yeah, 7.5 looks about normal. This one drops down significantly below, so I think that accounts for, even though you got one more above, I'd say 7.5. If you wanted to do it exactly, all you have to do is, I can't tell what that is. I said about 8.25. Yeah, I can't tell exactly what those scores are because we don't have enough gradations here. But you just plug in the numbers, add them together, divide by 8. Okay? Now, again, why the PowerPoints don't match the book, I don't know. They're supposed to be the same edition, but they're just not matching. Oh, okay, here's their questions. Which quiz had the highest class average? Oh, this is class average. I wasn't reading the problem well. This isn't yours, the class average. Which quiz had the highest class average? Quiz 3, obviously. Okay, very good. How about this one? Quiz 3, good for them. This one, which quiz experienced the biggest jump in the class average from the previous quiz? Say again? Okay. It didn't say the biggest jump up, did it? Biggest jump. 3 to 4. That was the biggest jump. Wasn't positive, it was a negative jump. 3 to 4, I think. Let's see what they say. Oh, they said what you did. 5. Okay. So they must have meant jump being increased. Okay. So you're right. I was. Huh? You jump up, you fall down. Okay, got it. Okay. So yeah, 5 was the biggest increase up. What's the next one? Estimate the difference between the class average quiz 2 and quiz 3. What are you going to estimate this one to be? About 7? How about that one? About 9? So what was the difference of? 2. That's what I would say. Let's see what they say. 9 minus 7, difference of 2. Good for them. Okay. Now, that's a type of graph called a line graph. You could have put bars there and made it a bar graph. Okay. Well, we don't go to bars. Okay, never mind. We're just kidding. Okay. So let's talk about a linear equation in 2 variables. Okay. Now, let's go back and see. What were our variables on this one? scores versus quizzes. There's the two variables, okay? Now, I'm going to give you a little bit more than what they're doing here. We usually do the horizontal scale as the independent variable. Pick a quiz, quiz 2, quiz 7. Give me a score from it, okay? So this depends on this, okay? So this is the independent scale, that's the dependent scale. Score here. Now, I won't go any more on that, okay? So a linear equation in two variables is an equation that can be written up in this form. I don't like this form. It is a perfectly good form, I just don't care for it. This they sometimes call the general form. AX plus BY is equal to C. Okay? X's and Y's are variables here. Okay? The A's, B's, and C's are numbers. Okay? So, A, B, and C are any real numbers in the world. They could be positive, they could be negative. They could be fractions, they could be decimals. They could be rational, they could be irrational. Any real numbers. But A and B cannot both be 0. C could be 0, no sweat. A or B could be 0, but not both. Because if both of these were zeros, that's not a very interesting equation. Because that'd be 0x plus 0y. What would be the only possible answer? 0, because there's nothing there. Okay? So A and B both can't be 0. But either one of them could be, but not both. C could be 0 anytime. So that's your general expression for a linear equation in two variables. Now, time out again. What makes this a linear equation? Anyone know? You haven't had it yet, so if you don't know, it's okay. Say again?
What do you mean by linear equation?
Okay, it is a linear equation. What makes it a linear equation?
What makes it straight?
When you graph it, you're going to get a straight line. Is that what you're saying?
Yeah.
Okay, that's true. But what? Just looking at that, I can tell you that's a linear equation. How?
Unless you could flip it and it'd still be the same thing.
Say again?
You could flip it and it'd be the same thing.
No, actually, here it is. Look at your variables. Variables. Not coefficients, variables. What's the exponent of this one?
1.
What's the exponent of that one?
1.
Okay, if both variables have exponents of 1, always a linear equation. If that was a fractional exponent, no, not. If it was 2, 3, 4, 7.5, anything other than 1, no, not a linear equation. So when you look at an equation, if both variables have exponents of 1, then you know it's going to be a linear equation. Every time. Okay? They didn't mention that, but no extra charge. Okay. Note, other linear equations in two variables could be written this way. Okay? This doesn't look very much like that, does it? But I could have subtracted 4x from both sides, and it would be minus 4x plus y is equal to 5. Your A would have been minus 4, your B would have been 1, and your C would have been 5. So yeah, it's the same. That's a linear equation. What makes it linear? Both variables have exponents of 1. Okay? How about that? Doesn't quite look like this, but what could I do? Yeah, you could add a 2y here. That'd be 3x plus 2y is equal to 7. 3 would be your A, 2 would be your B, and 7 would be your C. Yeah. So those are all linear equations. What makes them linear? Both exponents are 1. They're not written in standard form. That's what they call standard form. I don't care for standard form. It's not the most useful form, but that's what it is. We'll discuss the forms of linear equations in section 3.4. So that's coming up in the future. I'll give you a hint now. This is my favorite form. Anyone know what they call this form? When you solve for y, this is called, and you don't need to know this yet, slope-intercept form. That is such a neat form to have because you know so much information about it. If you had a graph, I could plot you that just like that. That one, I can't plot. I'd have to plug in numbers and figure out what they are and then get it. This is the most useful form, slope-intercept. That one's just as inconvenient as the standard form. I mean, they're fine, nothing wrong with them, but it's slope-intercept form is much easier to deal with. Okay. So let's move on to, all right, this is objective 2, I believe it is. Writing a solution as an ordered pair. Okay, a solution of a linear equation in 2 variables requires 2 numbers. Okay, you've got to have 2 numbers, 1 for each variable. That's why it's called a pair, because you've got to have 2 numbers. Okay? For example, a true statement results when we replace x with 2 and y with 13 in this equation. Let's see if that's true. Here's what I would actually do. Give me an x. You come up with an x. Any x. 2. Okay, very creative there, right? All right. 4 times 2 is?
8.
Plus 5? 13. So sure enough, what they said was true. Give me another x. I feel like a cheerleader. Give me an x. Okay.
56.
56. Okay. Yeah, that's what I thought. 56 times 4. That would be 214. Is that what you said? That's not right. Whatever. Give me some smaller x.
227.
Second?
224.
224 plus 5?
229.
229. There was another ordered pair. Give me a simpler x. 1. When x is 1? Oh, what do you say? Second? 10? Okay, we'll do 10. When x is 10, what you got? 4. So 40 plus 5 is? So your y is 45. Let's go back to the 1. What would that be when x is 1? 4 plus 9. Exactly. Here's the one I like best, because I'm really lazy. X equals 0. 5. Okay, that's my favorite. Okay. But you see, that works. Give me an x, and again, I said, usually your horizontal thing is your independent variable. Once you plug that in, it's really easy to get the dependent when you're writing in that form. So those pairs of numbers, 2, 13, 2 numbers, that's what makes it a pair. I've got to sneeze again, sorry. Okay. I think I squelched it. I'm not sure. Okay? This then makes it an ordered pair. We usually put it in alphabetical order, X, Y. So the ordered means it's alphabetical or it's independent dependent. That's really what it matters. It's a pair of numbers, 2 numbers, the order matters. The first one is the X, the second one is the Y. Always given that. The X value is always given first. Now, that pair of numbers, such as 213, is called an ordered pair, or pair because there's 2 numbers, ordered because the order matters. 13-2 would not work. If you plug in a 13 here, no, not going to come out 2. So the order matters. Big time. Okay, so let's do example 3. Decide whether each ordered pair is a solution or not to that equation. Is 2, 3 a solution?
Yes.
What would you get? 5 times 2 minus 2 times 3. The question is that equal to 4? Second?
10.
Yes, it is. This would be 10 minus 6 equal 4. Yes, that's an ordered pair that satisfies that equation, that linear equation. Okay? To see whether it is, substitute 2 for x, 3 for y. Plug it in, just like Glade. Okay? Is 5 times 2 minus 2 times 3 equal to 4? Sure enough, 10 minus 6, that is equal to 4. True. Okay? It's example 3. Let's do, thus 2, 3 is a solution to that linear equation. Okay? Let's do this one now. Okay? Will negative 2, negative 3 work? What will that give us? 5 times negative 2 minus 2 times negative 3. Is that equal to 4? No, that'll be negative 10 plus 6, negative 4. No, that does not form an ordered pair that is a solution for that equation. Could be a solution for some other equation, but not that one. Does that make sense? Okay, let's see how they did it. To see whether that's true, let me erase. Okay, to see whether it works, plug a negative 2 in for x, a negative 3 in for y. See what you get. That would be 5 times negative 2 minus 2 times negative 3. Is that equal to 4? No, negative 10 plus 6 will be not positive 4, but negative 4. Wrong answer. Okay? So that one would not be a solution. This one would be. All right. Good deal. Any questions on that? Okay. Thus, negative 2, negative 3 is not a solution for that linear equation. This one is, that one's not. All right. So let's complete some ordered pairs. Okay? Here we have negative 3x plus y is equal to 4. What value could we put in for y to make an ordered pair of 3 comma y? Well, let's see. If you put negative 3, and what's your x value? 3 plus y equal 4. Now what? Negative 9 plus y equal 4. Add 9 to both sides. And what does that give us? Y is equal to 13. So if I put a 13 in there, that should give us a solution. Okay? Because negative 9 plus 13, sure enough, is 4. Right? See how to do it? Plug and chop. All right. Let's see if we can just proceed here. Yeah. What you do is substitute 3 in for x in your equation, linear equation, solve for y. That's what we did. Negative 3 times 3 plus y is equal to 4. Negative 9 plus y is equal to 4. Add 9 to both sides. Oh, they even did it right, okay? They have been doing it horizontally. I like to do these vertically. And that'd be y is equal to 13. Yes, yes, yes. Okay, the ordered pair is 313. Okay. Now, here's something on these linear equations. For any given x, most of the time there'll only be one y. Only one. There will be a few strange exceptions to that, but most of the time, one and only one y. Okay? Sometimes there may not be any, but most of the time there will be one. Okay? Any questions? Make sense? All right. Oh, here's the other one. Let's erase this. All right. This time we don't know the x value, but we do know the y. So what do we do here? Negative 3x plus 1 equal 4. Now what? Second? Subtract 1 from both sides, and that gives us negative 3x. These add to 0. Equal what? 3. Divide by negative 3, and that gives you x equal negative 1. So negative 1, 1 should be your solution. Let's just see if that works. Negative 3 times negative 1 is plus 3 plus 1 is 4. Yes. Looks like that would work. Right? All right, let's see. Let me go on and erase this. All right. So substitute 1 in for the y, solve for the x. Okay? Exactly what we did. Negative 3x plus 1 equal 4. Subtract 1. Negative 3x equal 3. Divide both sides by negative 3. x equal -1. Cha-ching. So your solution, the ordered pair, is -1, 1. Good deal. Any questions? Okay. Let's now complete a table of values, not just one single value, a table of them. Okay? So complete the table for values for each equation. So here's x minus 3y is equal to 6. What x value would you put in to give you a y of -1? So what will you do? X minus 3 times -1 equals 6. That would give you x plus 3 equals 6. Subtract 3 from both sides, and that gives you x equals 3, because that adds to 0. So there would be x3, y is -1. 3 minus 3 times -1 is plus 3. 3 plus 3 is 6. Good deal. How about when x is 12? What would we do? 12 minus 3y is equal to 6.
You're wrong. 3 doesn't go to 6.
3 times, it goes 2 times.
Say that again.
You put 3
No,
on
it's
6,
minus.
it goes 3 times.
6 minus 3.
Okay. I'm not following. I put in,
6 minus 3.
Oh, minus 2, okay.
yeah, I put in the x of 12 minus 3y is equal to 6. Okay? Got it?
I thought it was, you was trying to see how many times 3 goes into 6. I was just wondering.
Not yet.
Not in the
We'll get there. What do we do next?
Minus 12.
Subtract 12 from both sides. And what does that give us? -3y is equal to -6. Now what? Divide by -3. And that gives us y is equal to 2. So let's see if that makes sense. 12 minus 6 equals 6. Yeah. Good deal. Does that make sense? Now, here's something else, folks. How many ordered pairs will make that true? We saw before 1 would make it true. Here we're seeing 2 will make it true. Infinite number. Pick a different x or a different y, you'll come up with another solution just about always. Just about always. So you have a whole string of possible ordered pairs for every linear equation. And we'll talk about that in just a bit. Any questions before we move on from here? Now, this was, I tell you, this is aggravating. That was, our example 4 was not their example 4 in the text. I think our example 3 was, wasn't it? It wasn't. Okay, sorry. No, it wasn't. Sorry, I wasn't paying attention. I don't understand. Why do they give different ones in the slide set? Do you want to do these as well? Or you think you got them knocked? Go on. Continue? Or come back and do these? Okay. Let's do the one in the book. Now, example 3 in the book is decide whether each ordered pair is a solution for this equation. This time the equation is 2x plus 3y is equal to 12. Okay? The question is 3, 2 a solution? You tell me.
Yes.
Say again?
Yes.
Yes, because 2 times 3 is 6, plus 3 times 2 is 6, 6 and 6 is 12. Very good. Okay? Is -2, -7 a solution? Okay? I think it's the same one, yeah. Does that work? That would be a -4 minus 21. No way that's going to add to be a positive 12. No, that would not work. Okay, let's go to example 4. The one they have in the book. Complete each ordered pair for the equation. This time we have y is equal to 4x plus 5. Okay? And 7, comma blank. What will make that true? Anybody? Say again, louder. When x is equal to 7, what is your y equal to? 33. Perfect. Because 4 times 7, 28, plus 5 is 33. So that would be 33. Okay? The B one is blank, negative 3. Okay, what will make that true? I can't hear.
Is that for the slideshow? Is that for what you wrote? Is that for the slideshow equation or the one that you wrote?
This is one in the book. This isn't on the slideshow. That one up there.
2.
Okay, let's see what we're going to do.
2.
Your y is negative 3, so we'll put negative 3 is equal to 4 times, and you're saying 2, okay, plus 5. Bingo, you got it. Okay? Oops, can't say bingo in Alabama, sorry. Okay, never mind. Oh wait, that's not right, is it?
That's pretty clever.
No, that would be 13. That wouldn't be negative 3. Negative 2 would work, right? Negative 2, that would give you a negative 8 plus 5 would be negative 3. That will give you a negative 2.
Close.
So, say again? Okay. So, rather than do it in your head, probably do it mathematically. That would be negative 3 is equal to 4x plus 5. Subtract 5 from both sides, and you get negative 8 equal 4x plus 0, divide by 4, and you get x equal negative 2. So that's where you got your negative 2. Good deal. Make sense? So there was example 4. These are the ones they did on the slide set. We already did those. Now example 5 was that one. The example 5 in the text. Let me erase this. How are we doing on time? Whoa! All right. This may be the last one we have time to do today. Example 5. Say again?
Are we taking that quiz right now?
It's the take-home quiz.
No, the other one that you had.
Yeah, I'll pass it out at the end of the class, right?
Take home?
Yeah, both of them are take-homes, yeah.
Can I go ahead and get it? I gotta go run.
Oh, okay.
And do I turn them on online or give it to you in paper?
What's that?
Do I turn them to you online or give it to you in paper?
Whichever you prefer. Paper is probably going to be easier because you got it in your hand. By the way, on this one, since you're leaving, let me go on and say this. Solve the equation, that's where you put your answer, and then check it, and whatever your answer is, that's what you put in the blank. Whoever made this one up really made it simple for you. So check your answers. You ought to get them all right, because you're going to check them all right. Okay. But let's go on and finish example 5 here. Complete the table of values for each equation, then write the results in ordered pairs. Okay, here's your thing. X minus 2y, I can't write. Minus 2y is equal to 8. Okay, here's your t-table, x, y, and this time we got a bunch of them to put in here. Okay, first one we're going to put a 2 in here. What y would you have there? Okay, you say 2, no, x is 2, minus 2 times y is equal to 8. Subtract 2 from both sides, and that gives you minus 2y is equal to 6 divided by negative 2, and that gives you y is equal to negative 3. So that goes to negative 3 there. Okay? Next one we're going to do a 10. So I'm going to erase this. Whoa, I erased too much. Okay?